And now going to part B. Part B is negative I minus 12i. That means you can say let z be equals to negative 5 minus 12i. Then we need to find the magnitude of the complex number, and we find the argument of this complex number, and then we substitute and we get the polar form. So the magnitude of the complex number r is, you remember the formula, so we shall just say it is the square root of what is x. X is negative 5 squared plus y. Y is negative 12 also squared. Then you press the calculator, we shall get the square root of 169. And the square root of 169 is 13 units. So the value of r, which is the magnitude of the complex number, is 13 units. After this, we need to find the argument. So we come and draw our Argand diagram in that format. This is the real part of z. This is the imaginary part of z. And then this is the origin at the center. Now we need to indicate negative 5 and negative 12. Negative 12, this becomes the positive. This is the negative side. Then 5 is somewhere here, and negative 5 is around there. So when we are to draw this complex number on the Argand diagram, which you already know, we shall dot this one downwards here, and then we dot this one to the side. And then here that is the point of intersection, and then we draw a straight line from the origin up to that point of intersection. Please use a rule. That is our complex number. Now we need to find the argument. This is our complex number, which we have just called z. Now the argument becomes the angle that will move from here up to where the complex number is. We know that this side is 90 degrees, this side is 90 degrees. So we need to find this small angle here, and this small angle here. Now the distances from here up to here is 12. And from here up to here is the same as from here up to here, which is 5. Please go on and extract the triangle. I'm trying to save time, but we have done that. Now, for us to get this angle, let me call it beta. I can just say tan of beta equals to, what is the opposite? The opposite is 12 out of adjacent, which is 5. So our angle beta becomes tan inverse of 12 out of 5. Make sure you have drawn a triangle to make your work easier if you are a beginner. So tan inverse of that is 67.38 degrees. This is just this small angle beta. Now for us to get our theta, which is the argument, now theta argument becomes 90 plus 90 is 180 degrees plus 67.38 degrees. So plus 180. This means that our argument is 247.38 degrees. This is the argument. It is not the principal argument, but it doesn't matter. We can use that argument in the polar form. So now here we would say, now therefore, because we know that it is given by r cosine of theta plus I sine of theta, then we close the bracket. Then now we substitute what is r. Our r was 13. So we say here we shall have 13 into cosine of the angle theta. We use the argument. This was just a small section, but the argument is this, which is 247 to 47.38 degrees plus, don't forget I, sine of the same angle to 47.38 degrees. Or somebody could just say from z equals to r comma theta, then now they have 13 comma, what is the angle, which is the argument, is to 47.38 degrees. These two answers are the same, this one or this one. The two answers are going to work. What if somebody had used the principal argument instead? That is by measuring the angle clockwise in this manner. we are going to get the same answers. Okay, they are still going to be the same answers. Why? Simply because we know that the complete revolution is 360 degrees. Since we know that it is 360 degrees, we know that if we measure anti-clockwise, we get positive angles. Clockwise, we get negative angles. That means that, for instance, one cosine of maybe 6 degrees. This is the same as cosine of negative 300 degrees. If you press the calculator, you get the same values. Or maybe cosine of maybe negative 120 degrees. This is the same as cosine of what is the remaining balance from 360. 360 minus 120. It is the same as cosine of 240 degrees. So it doesn't matter. Like for example, this is a principal argument because it is lying in the range that we looked at. But this is just an argument which is lying outside the range. But the cosine of argument is the same as the cosine of the principal argument. It also applies to sine. Let me say one again. For sine, for example, sine of which angle? Just say any angle. Maybe 180 degrees. This is the same as the sine of negative 180 degrees. They are both the same. Or maybe use another value. Maybe sine of negative, which value can we use? Maybe 150 degrees. This is the same as sine of, then you get the balance 360 minus 150, 210. But since here there is negative, you can maybe even positive 210 degrees. So it doesn't matter. Like for in this case, this is the principal argument because it is lying in our case. But this is the argument. So the sign of the principal argument is the same as the sign of argument. So this is the solution, and let us go. And now for part C is 2i minus 3. So you can say let the complex number z be equals to 2i minus 3. Then we need to find the magnitude of this complex number and the argument for us to find the polar form. So the magnitude given by r is given by the square root of x, negative 3 squared, plus y, which is 2 squared. We have learned that already. This gives us here square root of 15, square root of actually 13, because 3 squared is 9 plus 4 is 13. So this is the value of r, which is in sad form. This value is correct. But if you want to write your value in decimal form, then you just press square root of 13, which is 3.6056056 units. Both are correct. You can write the answer in decimal or in sad form. After getting the magnitude of the complex number, let us now find the argument of that complex number. So that here we have, this is the imaginary axis of z, this is the real axis of z. Then you come and then you represent your values. On the real axis, we have negative 3. So negative 3 is here, the corresponding positive is there. This is the origin. On the imaginary part, we have 2. So positive 2 falls there, the corresponding negative 2 is there. Then we draw the complex number. It will be in this format. These two are going to intersect there. We know how to plot that already. Then you draw a straight line from the origin up to where the complex number is. I now say that is my complex number, which you had called z. And then you find the argument of this complex number. That is the angle from the positive x-axis up to where the complex number is. But you know that this side is already 90 degrees. So we need to just find this single angle here, which I'm going to call alpha. Now, go on and extract the triangle as we did in the previous examples I'm going to use it from there. From here to up there, from here to up here is 2, and then from here to here is 3. So I'm going to say tan of alpha equals to opposite to the angle we have 3 out of adjacent to the angle we have 2. That means alpha becomes tan inverse of 3 out of 2. You can use other units like sine and cosine, though it is longer. 3 divided by 2, tan inverse of the answer. This gives us here 56.31 degrees. That is just this small angle here, this small section. Now, how do you get the argument, which is the whole angle from here up to where the complex number is? Therefore, argument now becomes, we have 90 degrees already, plus the small angle we have obtained as 56.31 degrees. Yes, and then we add 90. 146, this gives us a 146.31 degrees. That is the argument. Now you come and say now, therefore, because you know that the polar form is given by z is r open bracket cosine of angle plus I. Don't forget that sine of the angle. This means that we need to substitute for r. You can either substitute for root 3 or 3.6056. So let me just substitute for root 13, not root 3. Root 13 into cosine. What is the angle? 146.31 degrees plus I sine of the same angle 146.31 degrees, and then you close the brackets. That is the answer. Or if you want to write in the other form of z equals to r, comma, theta, that means here now z becomes, what is r? R you can choose either root 13 or a decimal point. But let me choose root of 13, then you put comma. What is the angle? 146.31 degrees. So this answer is correct, and this answer is also correct, depending on which one you want to use. Even you can use 3.6056 as the value of r. So this is the solution to part C, and this is the overall solution to example 1.